itself is a function of angle. So from this formula, one thing is very clear: the directive gain is always greater than 1, but that too in a particular direction, because not in all direction, because once you really change your direction, okay, only in a particular direction. See, that direction is direction of communication of interest. Okay, only in a communication, only if you want to make a communication in a particular direction, if you measure the directive gain in a particular direction, okay, because you are concentrating power on a particular direction, if you measure the directive gain in that direction, then definitely, as per our discussion, the numerator is always greater than the isotropic radiator. But if you really go to outside the direction of interest, then definitely the dg may be less, we do not know. So always you have to be in a region of interest. Okay, so my dg in general in the direction of interest, directivity dg is okay. So dg in the direction of interest is greater than 1, or otherwise I will tell you one more parameter: directivity. Okay, directivity. So directivity is equal to maximum directive gain. Directivity is equal to maximum directive gain. Okay, maximum directive gain, because the gain, because you will have different directive gain, you will have different gain at different point. But once if you stand here, you will get maximum directive gain. The maximum directive gain is called directivity. Okay, that one more diagram I will draw for clarity. Say for example, in first case you are having isotropic antenna. What it will do? It will radiate uniformly in all direction. In the second case, I am going to use practical antenna that will radiate only in this direction. Now you know that the diagram, the radiation pattern diagram, where r is constant. Okay, where r is constant, that means what? Your distance from the antenna is always constant. What you have to vary? You have to vary your angle. So when I stand here, what is the power received due to isotropic antenna? What is the power received due to practical antenna? Definitely I am getting more power from the practical antenna. Practical antenna, I have taken a green color. Okay, because this value, this radial distance from the origin is greater than this one. And if I go some other place, here also I am getting more power as compared to this one, but as compared to this one, this is less. That's why in this direction I am getting maximum gain, maximum directive gain. Okay, in this direction, maximum directive gain I am getting, directive gain. So once if you know the direction of maximum gain, maximum directive gain, then you measure the gain there. That is called directivity. That is called directivity. Directivity means what? Maximum directive gain. Because once if I stand here, my directive gain will decrease. But if I stand here, my directive gain is something similar to isotropic. But once if I go here, my isotropic is behaving better. Okay, my practical antenna is behaving worst, because your aim is to concentrate power only in a particular direction, but you are going into the other direction. That means what? Your practical antenna has the ability to radiate the power only with the solid angle, with the beam width of this one only. Once if you go outside this red color region, then your practical antenna will not give you any significant advantage over your isotropic antenna. That is the idea. Okay, so practical antenna you are getting gain, but only for a particular angle, particular beam width only you are getting gain for a particular beam width only. So the maximum directive gain is called directivity. But one thing is clear, that directivity can never be less than 1, because at least because you are measuring the maximum directive gain. Okay, see, once if you stand here, definitely this value will be greater than this one. So definitely the directivity is always greater than 1, but the directive gain can be anything. Please remember very clearly, directive gain can be anything. dg may be greater than 1 or may be less than 1, or dg may be 1 also, we do not know anything. But directivity is, because directivity means maximum directive gain, but d is always greater than or equal to 1. D is always greater than or equal to 1. Because if D is not greater than or equal to 1, that means you are designing some antenna. It is not able to radiate. It is not able to give the advantage only in a particular direction, at least in some direction. Then what is the use of designing that practical antenna? That is waste only. That means what? You design some antenna, definitely that has to give some advantage over the isotropic antenna, at least in some direction, at least in some direction. Okay, in that direction, you have to measure the directivity. So once if you measure the directivity, maximum directive gain, that is always greater than 1, it will never be less than 1. It will never be less than 1. Okay, so that is a relation between the directivity and directive gain. And this directivity for a particular antenna, you will have only one directivity, because a particular antenna will radiate maximum power only in a particular direction. It will not radiate in all direction. Only isotropic antenna will radiate uniformly in all direction. Okay, there you cannot clarify maximum or minimum like that, because it radiates uniformly. But all other practical antenna will radiate the energy only in a particular direction. Okay, that means you are having directivity really for a particular practical antenna. You will have only one D value, but DG value can be anything. DG is function of angle, but D is in reality for a practical antenna you will have only one D value, because for a function if you calculate the maximum value, definitely only any one of the value is going to be maximum, only one value. Okay, you are having some mathematical function. If you calculate what is the maximum value, definitely you will get only one value. You will not get more value. So for a practical antenna, only one directivity is present. Okay, for a practical antenna, for practical antenna, the two particular antenna, because once if you change the antenna, then directivity will change. For a particular practical antenna, there is only one directivity. There is only one directivity, because it can radiate. It can give the maximum radiation only in a particular direction only. It cannot give in all direction. Okay, that's the idea of the practical antenna as compared to the isotropic antenna. So suppose I have an antenna like this. Okay, first case I have an antenna like this. My source is here. Okay, I am having total power here that is radiating uniformly. In the second case, I have designed some antenna. Okay, I'll put some other color. In the second case, I designed antenna. It is giving radiation pattern like this, but the directivity is in this direction. Directivity is going in this direction. Now one more antenna I am designing. The direction of the directivity is same, but what is happening? The beam width is decreasing. Okay, okay. For the third antenna, say this is isotropic antenna. This is isotropic antenna. This is practical antenna. Okay, practical antenna 1, and next one is practical antenna 2. Okay, and the next one is I'll draw the practical antenna 3. Okay, practical antenna 3 I am having like this. Okay, this is practical antenna 3. Now I am going to ask you one question. If you have an antenna, okay, you are having practical antenna, 3 practical antennas. Which antenna you can use for highway purpose? Because you are having highways. Please imagine that nearby highways there is no villages. Only you have to concentrate your power on highways. Okay, you want to cover the people who are going on the road only. Which antenna you can use? Isotropic or practical 1 or practical 2 or practical 3? Which one will be better? Huh?
Practical 3, sir.
Yes, practical 3. Because practical 3 antenna is covering less angle, but it is having the ability to go longer distance. Okay, then it will have the ability, because as it is covering only smaller angle, it will have the ability to go to the longer distance. Okay, so what is, once if we compare all this antenna, what is constant? The total power radiated in all antenna has to be constant. Because when I'm going to analyze the performance of the antenna, what has to be constant? The total power radiated by antenna 1 practical antenna isotropic and practical antenna 1, 2, 3 has to be same. Okay, 2 and omega radiated 3, everything has to be same. Okay, so once if it is same, then one thing is very clear, the isotropic antenna is covering all direction, okay, entire direction, say, but again the beam width of first antenna is less than the isotropic because it is covering only in this direction. But if you take antenna 2, then it is still less than antenna 1, then antenna 3 beam width is still less than 1. Okay, what